Alright, so we're moving on to lesson 4. Sorry about the written paper. Experiencing some technical difficulties with my printer, so we're just going to do it with some paper and some chicken scratch. Alright, so lesson 4 in unit 3. We're going to be talking about the written equations from writing equations for lines. Those are linear equations from written descriptions. And from this one, you should be able to do that. You'll be able to write given some written descriptions with some sentences, be able to derive the equations for that line. Okay, so before we do that, we're going to talk more about what just an intercept is, and we already kind of know what the y-intercept is, and we've been saying, hey, the y-intercept is where the y value when some function, we'll call this function blue, crosses the y-axis, right? This blue functions be negative, right? And so the y-intercept is what the value of y when it crosses the y-axis, right? And so it's the value of y when it crosses the y-axis, right? And what do you notice about the x value when this happens? Well, x will equal 0 at this point, right? Our x value for when it crosses the y-axis is 0, right? So this point would be, say this, this is some point value of y, 0. It's going to be 0, comma, whatever y is, right? It's because x is 0, right? And conversely, if we look at our point of our x-axis, our x-intercept, I'll call this, we'll leave this in red, I guess. Our x-intercept, come on, don't fail on me now, red. Alright, I guess we'll do it in blue, or in orange. Give me orange, there you go, orange. Our x-intercept is the same thing, it's our value of x when it crosses the, you got it, x-axis, right? So like here this would be our x-intercept, right? And then so this would be x, comma, right? And what is the y value? Well, you guessed it, it's 0. So it's the opposite. The x value, the y value for this is 0, right? So you could say it's an intercept. An intercept is the value L-V-A-L-U-E of a variable in the equation QUA when the other variable equals 0, right? So let's look at our our function in standard form. So if you look at this function in standard form, right, it's gonna be, see, I used x, or so it's gonna be equals some constant, right? And then remember our it's gonna be ax plus by equals c, right? Well, let's look at if x was 0, if x equals 0, right, then y would equal c divided by b. C divided by b right, and that would be our y-intercept. Right? That would be our y-intercept. Yeah, that seems right. Yeah, okay. So now, if we had, because now say we had our y equals 0. Okay, so now if we had y equals 0, forgot the plus sign over here. It still be positive, I don't need to do that. Alright, so it would be a x plus b times 0 equals c Then our x intercept is going to be whatever c divided by a is. Whatever c divided by a is. Which is going to be a constant, right? It might be a fraction, but it's still going to be a constant. Right. So that's that. Let's see. So let's put this to work in an example here, among some other things we already know. All right, so here is a line, and all they tell me about this line is that the x-intercept, the x-intercept is 4, and that the y-intercept is 2. It doesn't seem like a lot of information, but it actually is, if you think about it. Because I can write, it's like, hey, and then find an equation for this line. Because if you have one equation for the line, you can find any equation for the line. So let's just start with the good old, my favorite points, or slope-intercept form, right? So y equals mx plus b. Mx plus b. All right. Well, I know my y-intercept already, right? So I can say y equals negative 3.2. Okay, x is going to be x, and now all I need to know is a slope from this line. Well, I know that a slope is a change in x over a change in y. Okay, so my slope is a change in x over a change in y. A change in y over a change in x. Right? So a change in y over a change in x. Remember that my change in is my final minus my initial. All right, so, well, if this is my x-intercept, what point does this relate to? Well, if you remember, my x-intercept is an x value and then a 0, right? So that this point must be, I must have a point at 4 and 0. Okay, and then I have another point at my y-intercept at negative 3, right? And my y-intercept is a 0 and a negative 3, so it's going to be down here actually. Okay, so this point, this is going to be like a negative 0 and a negative 3.2. So this line looks something like, it's not going to be exactly like this, just ballparking it, right? it intercepts at 4 and 0 and negative 3 and 2. It looks, you know, something like this. Something like that. Okay? So we got something going on here, right? So now this slope, how do I figure out this slope here? Remember, it's my change in x, my change in y, and I'm just going to be like, okay, well, I'm going to say that this is my initial and this is my final. I'm going from left to right. Okay? So, this is going to be my, I'll call this my final points. Running out of ink. My final, I need to go, and my initial. Okay, so I'll set up some fractions here. Minus, minus. All right, now my change in y. So my initial y, my initial values are going to be last. So I'm going to start with my final values. Right? So my initial y, or my final y, my finals are first. My final values are first. All right, so they're going to be, my final y is 0, and my final x is 4. All right, I got that one. Now I'm going to go with my initial values. Now, I'm looking at the slope, and I just know that I should have a positive value when I'm all done. So if I don't get a positive value at this thing, I should go back and look at my numbers again. Okay, so now my initial values is my initial y is a minus a negative 3.2, so it's going to be a positive, because a minus minus a negative is a positive 3.2, and then a 0. Alright, so now I have a 0 plus a 3.2 is going to be equal to a 3.2. 4 minus 0 is going to be a 4. 4. So it's going to be 4 divided by 3.2. Let me pause this just for a minute. Well, I'd get my calculator out. So 4 divided by 3.2 came out to a nice, clean 1.25. And 1.25 is 1 1/4, which I'm going to round up to 5. I'm going to not round up to, but I'm going to convert to 5 5/4. 4/4 is 1, an extra quarter is 5/4, right? So it's a positive slope of 5 up and for 4 over. Okay, so now I have my slope, which I'm just going to take right here, move up into my slope spot, put in 5/4. So now I have my equation. And with that equation, I can do whatever I want to with it. And let's see if I wanted to put this in point slope form, right? Just some real quick stuff. I need to move it. First get rid of my fraction. Okay. Remember, point slope is y minus my point, right? Any one of these points. Okay. Times, and then it's going to be equals m times, x minus x, so any one of those points. Okay, so let's go ahead and get rid of the 4 first. So we're going to multiply everything in this function by 4. Right, so this is going to be 4y equals 5x minus 12.8. Okay. Double check my math in my head. I'm not always trusting. 3.2 times 4 is equals 12.8. Yeah, that's right. Okay. So from there, I'm going to now I'm sorry, I misread the question. Let's just go to standard form, which is ax plus by equals c. All right, so from here, we're going to go ahead and just take this x and move it over to here. We're just going to make it a negative 5x plus 4y is negative 12.8. And now we're just going to multiply everything by negative 1 to get this to be a 5x. So it's going to be 5x minus 4y equals 12.8. So that's how you go about that one. Okay, we'll move on to a different one right now. All right, so here's a line passes through these 2 points. Let's find all the equations for it. All right, so in order to find all 3 different equations, I guess in order to find, well, it's just one equation and we're going to put it in 3 different forms, right? So the best way to do this is we can either find it in point-slope form or we can find it in slope-intercept form first. First thing you got to do for both of those is find the slope of the line. All right, so in order to find the slope of the line, you have to first identify which one's going to be your initial point, which one's going to be your final point. It doesn't matter which one you choose. If you work from left to right, it'll be the same as if you work from right to left. Like this would be my most left point because that's negative 3, and this would be my most right point because that's 4. So on a number line, looking at the x direction, right? If this was just my x-axis, right? If this was just the x-axis, I'm just looking at my x points, right? Negative 3 would come first, and then 4 would come second. So whatever direction this line is going, right, it's going to be going from this point to this point. We'll call this point A and this point B, right? But I mean, if I go from this point to this point, it'll still come out to be the same slope, right? And here's a y-axis, right? You can see here it's coming up from up high, which is the 7, to down low, which is the 4. So this is going to have a negative slope. Okay, so you can kind of like envision in your mind that this is going to at least have a negative slope, just as a brain check. Okay, so we're going from a negative to a positive x, then we're going from high to low, right, in my y's. So I'm going to have a negative slope. I should have a negative slope after I do my math. All right. So let's go ahead and do the math. I'm going to prove to you that you can start with B and end with A, moving backwards, and still have a negative slope. Okay, so I'm going to say that this, doing it backwards, is my final, or this is my initial, and this is my final, even if I guessed it wrong. Okay? Even if I guessed it wrong, if I'm consistently wrong doing my slope math, I'll still get the right slope, and I will still get the right value of the slope. Like it'll still be the right numbers, and it'll still be the right sign. All right, so my slope is my change in y over my change in x. Okay, that's right. All right, so my change in y, remember a change is your final minus my initial. All right, so set up my equation. Get ready to drop points in. All right, so now I'm going to find my finals. My final x's and my final y's. I'm just going to cover up the stuff I'm not going to use. All right, I'm going to cover up the stuff I'm not going to use. All right, so I'm going to find my finals. My final x's and my final y's are what I'm getting dropped in right now. Use orange as my final points. Maybe I won't. How about I use pink as my final points? Pink is my final points. All right, my final x is going to be a negative 3. And my final y is a 7. All right, negative 3 is my final x, and negative 7 is my final y. Okay, now I'm going to move on to my initials. Final minus initial. Okay. Now I go over to blue is going to be my initials. Okay, Now, so my initial x goes on my bottom. All right, so it's going to be minus a minus 2, which is a plus 2. All right, and then I'm going to have a minus a 4, which is on top. Okay, so now it's going to be some pretty easy math here. Going to end up being my slope is 7 minus 3, or 7 minus 2, 4, 7 minus 4, which is 3, and then negative 3 plus a 1 plus a 2 is a 1. Okay, so my slope is going to be 3 over 1, or just 3. Okay, so that's my slope. All right, so now I can use either the point slope form or the slope intercept form. I'm going to use the point slope form. Okay, so I'm going to set up my equation before I even start looking at what I'm going to drop in. Okay, start up with 2 sets of parentheses. The right hand side has a gap to drop in my slope. Associated with, remember, slope always goes next to the x, right, in the point slope and the slope intercept. Okay, slope goes with the x. Okay, then I go with a minus and a minus. All right, now I'm ready to drop my slope in. Slope comes in down here, goes to the 3. All right, and now I just pick a point. I'll pick the blue point. Why not? So my y value is a minus 2. I'm going to take this minus 2, and I'm going to drop it in right here. So if I drop in a minus 2, I've dropped a 2 in, but that minus sign's got to get dropped in right here. There's already a sign there, so that minus sign's got to flip sideways and get dropped into that plus sign, because minus a minus 2 becomes a plus. Okay? And then this 4 gets dropped into right here. A minus a 4 is still a minus a 4. Okay, so there is my equation point slope form. Sweet. All right, so now that's in point slope form. Now I'm going to rewrite this into, take this into standard form, and then I'll take it into point slope form. Okay, the first step in both is going to be distribute that 3. Just distribute, you got to clear the parentheses, right? On both sides. There's nothing to clear on the left hand side with the y's. So nothing to do, just got to drop the parentheses. It's going to be y plus 2. And then over here, it's going to be 3 times everything inside of that, right? So 3 times x, a positive times a positive is a positive, 3 times x is a 3x, a positive times a negative is a negative, and a 3 times a 4 is a 12. Okay, so there. Now this is where I start, this is where I have to start splitting sides here, right? So my standard form and my point slope form, where the difference comes from. Okay, standard form is going to be, remember, your ax plus by equals c. And then my point slope form is my function form, is y equals mx plus b. Right, so this is where I'm going versus where I'm going different sides here, right? The y equals mx plus b is pretty easy. I need to get the y by itself. So this negative 2 doesn't belong on that side. So I got to bring it over to here. When I do that, this plus sign changes from a plus to a minus. Okay, so when that happens, it becomes y equals, can't combine in like terms, so the 3x stays the same, and then a minus 12 minus 2. Okay, and then so 3x minus 12 minus 2 is a y equals 3x minus 14. All right. My y-intercept for this is going to be negative 14. Alright, so it's intersecting pretty low. Alright, that's my y-intercept. Okay, so over here, I got to do the same thing, right? Except my c ends up on the other side. Right, so over here, this still has to go over to this side, and this goes over to here. Okay, so this line is going to look like this. Negative 3x, because this sign is going to change from positive to negative. Okay, and then, again, this is going to be turned into negative 12 minus 12. All right, and then we still have the y on that side. All right. But we usually like to lead with the x, because ax plus by equals c, and a is normally positive. Okay, so we're going to multiply everything. Multiply everything. Oh, that should be 2. Whoops, that should be 2. Okay, so I'm going to combine this. Combine that into 14. Negative 14 equals negative 14. I'll rearrange this in the proper format. Negative 3x plus y equals negative 14. And like I said, this needs to be negative. But this negative 3 is normally not, you normally don't put that positive, right? So I'm going to multiply this and this and this by a negative 1, by a negative 1, by a negative 1, by a negative 1. Not to be confused with raising it to a negative power. Negative 1, right? So it's all just flips the signs. 3x minus y equals 14. Okay. So there you go. So something to notice here, the constant, as long as y is 1 on this side, right? The constant over here is going to be, there's more to it than that. The absolute value of the y-intercept. You have to evaluate the sign of that. So, anyway, I hope that helps. Yeah, that's good enough for this one. Hope you guys have a great day, and we'll move on to scatter plots next.